Welcome to springlib.
So let's draw a free body diagram. We have force tension going straight up, and then going straight down is force of gravity. We're going to say that for part A, the sum of forces in the y direction equals ma. And so we know that A is going to be equal to 0.15 times the acceleration due to gravity on Earth's surface. Therefore, force tension minus mg will be equal to 0.15 mg. At this point, we know that force tension is going to be equal to 1.15 mg. And to find force tension, we can simply say that this is going to be 1.15 times the mass of 265 kilograms times the acceleration due to gravity, 9.8 meters per second squared. And we have that force tension is 2.99 times 10 to the third newtons. Now, for part B, we know that the net work done is going to be equal to the net force times d cosine of theta. We know that this is going to be equal to 1, so this will simply be 0.15 times mgd. And we can actually solve, so the net work done is going to be 0.15 times 265 kilograms times 9.8 meters per second squared times the distance of 23.0 meters. And this is giving us 8.96 times 10 to the third newtons. So this is the net work done. This is the magnitude of the tension force. And then for part C, they want us to find the work done by the cable. This will simply be the force of the tension times d cosine of 0 degrees. Once again, this will be 1, and this will be 2.99 times 10 to the third newtons times d, the distance of 23.0 meters. And so we find that the work done by the cable will be equal to 6.87 times 10 to the fourth joules, rather. My apologies. Yeah, my wrong units. My apologies. Work is in joules, force is in newtons. My apologies. So this would be our answer for C. And then for part D, they want us to find the work done by gravity. So this would simply be equal to negative mgd cosine of theta. We know that this is, again, 1, and this will equal negative 265 kilograms times 9.8 meters per second squared times the distance of 23.0 meters. And we find that the work done by gravity is going to be equal to negative 5.97 times 10 to the fourth joules. That would be our final answer for part D. And then finally for part E, we're trying to find the final velocity. So we know that the net work done is going to be equal to the change in kinetic energy. So this will be equal to 1/2 m times v final squared minus v initial squared. We know that in this case, v initial squared is going to be equal to 0. So essentially, the final velocity will be equal to the square root of 2 times the net work divided by the mass to the 1/2 power. And so this is going to be equal to 2 times 8.96 times 10 to the third joules divided by the mass of 265 kilograms, all to the 1/2 power. We find that the final velocity is equaling 8.22 meters per second. So this will be our final answer for part E. That is the end of the solution. Thank you for watching.